EE World, I'm Martin Rowe. We are at APEC in Long Beach, California. This is the CleverScope booth. And CleverScope is a company based in New Zealand that has an oscilloscope that is specialized for power measurements.
That's correct.
So Ken Henderson from CleverScope, if you could explain how your oscilloscope works, what it does. And we know what an oscilloscope is, but tell us about this setup that you have here.
Okay, so what's different about our scope is it's basically a USB oscilloscope, but what is special about this scope is that each of the input channels is isolated. So the isolation voltage there is up to 2000 volts DC.
Okay.
They're all independently isolated, and they all have a very good common mode rejection, which is what you need if you want to make measurements in a power converter. So what's happening in a typical power converter is that the switching edges are very fast. So you're getting edges which are switching in about 10 nanoseconds maybe. If you want to measure the high side gate voltage in that converter, you need a probing system with a very high common mode rejection. And that's what we can do with this scope.
Okay.
Okay. So in this, what we've got in this setup here is we've got these channels on this oscilloscope connected to the high side transistor and a small GAN switching bridge. What we're measuring here is the high side drain source voltage, the current in the high side transistor, and the gate signal on the high side transistor.
Okay. So you've got a sort of standard probe here.
Yeah.
And then this device? This is
okay. So this standard probe here, this is a times 100 probe measuring the drain source voltage.
okay.
And then this here is what we're calling a saturation probe. What that's doing is clipping off any signal larger than 1.5 volts so that you can zoom into the transistor saturation voltage with high resolution.
I see.
Okay, so we can see that on the waveforms here we have the drain source voltage there, which is in this case it's switching 50 volts. And there's the saturation voltage, which we've clipped off at 1.5 volts so that we can get high resolution there on the saturation voltage of that transistor. There's the current in the transistor. This is ramping up because it's an inductive load. Because we've got the voltage and the current, we can work out the conduction resistance of that transistor. So that's the drain source on resistance. Yep.
Okay.
We've got voltage and current. We can work out the power in the transistor. We can integrate that to give the energy in the transistor.
Okay.
So what we're focusing on is making a system for high resolution measurement of switching losses, conduction losses, any measurements you want to make in a power converter, while they're all switching through high voltages, and we're rejecting those high voltage interferences from the signal.
Very good. Thank you.
Okay.